1.
Okay. So how do we add two functions?
So, where'd it go? What the heck? You put them together, and then you do, like this one, you do 6x squared, and then you do 3x to the half, I think.
Well,
That's right. I mean,
you're correct in that we do combine them. In other words, we're going to take that function and we're going to write it like this: 6x squared minus x to the 1/2. And we're going to add it to this function, which is 2x to the 1/2. Whenever you're combining terms, the only things you can combine are like terms, at least if everything is being added or subtracted. It's not the same as multiplication. Okay, so the total number of those that we have is 6x squared. Now what's this? What is minus x to the 1/2 combined with plus 2x to the 1/2?
it would be plus 1 to the 1/2.
Plus x, yeah, plus 1x, but we don't need the 1. The same way that the 1 is not there, but it's implied.
Yeah.
All right.
Okay.
Good. Now, subtraction is exactly the same thing. The only thing you got to be careful with subtraction is if there's more than one term, then you have to subtract both of them.
Okay.
In this particular problem, there's only one term for g of x. So how am I going to subtract the two of them? I'm going to write it what? Gx squared minus x to the 1/2, and then subtraction. And just for clarification, I'm going to put that in parentheses, even though you don't need it in parentheses here.
Okay.
In other words, because there's only one term, the next step is to get rid of the parentheses, right?
Yeah.
Which gives you this.
Minus 3x.
And what is that? Now combine everything.
Wait. Wait. Oh, I got confused.
Doing what? We're doing number 2.
Yeah, I didn't. I thought you just subtracted the x and then the 2x. I must have did that wrong.
Okay. So what's our answer here?
6x squared, and then minus 3x.
Minus 3x to the 1/2.
Yeah.
In other words, the 1/2, the exponent doesn't change. That's the only reason we're able to combine those two terms, because they have the same exponent. It's not like multiplication, where if I'm multiplying, I add the exponents. But when you're adding and subtracting, it's not like that at all. Okay, so in this one, I'm going to take this quantity, and here you want to make sure you use parentheses. That's f of x, okay?
Okay.
I'm multiplying it by g of x. So let's even put that in parentheses. Now, how do you do this multiplication?
So you can do 12x to the what that be? 12x to the 2? No.
What do you do with the exponents?
You add them?
Okay, what's 2 plus 1/2? In other words, I'm doing this step right here.
5
5 halves.
over 5 halves.
That's what 2.5 is. Okay, now you still have to do that times that.
So that'll be minus 2x to the fourth.
What do you do with the exponents?
You add them.
You don't multiply them, you add them. What is 1/2 plus 1/2?
Oh, 1.
Okay, and we don't need to write it. So there's our answer.
Okay.
Okay. Biggest thing people get confused on with these exponents is they want to, you do one thing when you're adding and you do another thing when you're multiplying or dividing. So be very clear with what you're doing. Okay. Now I'm going to do number 4 over here because I need a little bit more room. There's the f of x on top. And there is the g of x on the bottom. So, what can I do here?
Can you get 3 or 3x to the 5/2?
What are you going to do with the exponents?
Oh, divide them?
Subtract them.
Subtract them.
Remember in the previous problem, we added the exponents when we were doing multiplication. When you're doing division, you subtract the exponents.
So it'd be 3/2?
Uh-huh. And now I also have to do this part right there.
So you would do 2? Would it just be 2?
You're close. The 2's in the denominator. And I need a minus sign. So it's 1/2. It's actually 1/2 x to the 0 power, but anything to the 0 power is 1, so it just becomes 1/2.
Okay.
You do have to subtract it. Let's talk about a principle here. If I have a plus b divided by c, I can divide that up into 2 fractions. That's exactly what we did in that problem. Is we divided it up into that fraction, and then we have to subtract that fraction. And that's why we're subtracting 1/2 and not dividing the whole thing by 2. Okay? However, it's very important not to make the following mistake. A over b plus c. What's that equal to?
A plus a over b, I think.
No, you can't simplify that.
Oh.
It's definitely, you cannot split it up into 2 fractions. In other words, it's definitely not equal to a over b plus a over c. Okay? So the only time you can split it up into fractions is when you have a kind of a single entity for the denominator. And that was what we had in that problem. We had 2x to the 1/2. Okay, that was a single entity. There wasn't any addition or subtraction going on. Believe it or not, what makes math hard is addition and subtraction. It's not multiplication. Multiplication's much more straightforward, whether you're dealing with variables or fractions or exponents. It's much easier to multiply than it is to add. If I tell you to add 1/4 plus 1/3, my goodness, you got to go find a common denominator, convert each fraction, and then you add the tops. But if I tell you to multiply 1/4 times 1/3, piece of cake, multiply the tops, multiply the bottoms. Much, much easier. Well, that applies whether you're dealing with fractions or variables, exponents. So always be real clear what it is you're doing. You know, we were multiplying and dividing there. We were adding and subtracting there. All right. It's another way of writing f of x.
The f x and then g of then f. Wait, what?
It's another way of writing 3 times x to the minus 1. What's the negative 1 exponent mean?
I don't know.
It means the reciprocal.
Oh yeah, the reciprocal. Okay.
In other words, negative exponents never mean negative numbers. It just means 1 over x. If I saw x to the minus 2, that would be 1 over x squared. Okay? So in this case, I can write this as 3 over x. That's f of x. Okay? Now, g of x, I don't need to write it in an unusual way. It's fine as it is. Now, if I said to you, what is f of 6, what would you do?
Put the 6 in for x.
Okay. If I said to you, what is f of x plus 1, what would you do?
Add the 1 into there.
You'd put in whatever's in the parentheses, x plus 1, in for x. That's the point I'm trying to make. You're right, you just add 1, but that's not really what you do. What you do is you take whatever's in the parentheses, no matter how complicated it is, and you substitute it wherever you see x. In other words, if this were a more complicated function like that, then you'd have to substitute that for that x, and you'd have to substitute it in parentheses with this x. So that's what it means to have something in the parentheses. Okay?
Okay.
So they want to know f of g of x. Well, f of g of x, and that's how you pronounce that, is equal to what? F of what?
3x negative 1.
Hold on. What's g of x?
X minus 8.
So it's f of x minus 8. That's what that means.
Okay.
Now what is that equal to?
3x.
Hold on, not 3x. The x is in the denominator.
I don't know.
Okay, take whatever's inside the parentheses and substitute it for x in the f function.
8 minus, what?
Hold on. Don't get confused. You can eliminate this for the moment now. We've got the whole problem right here. In other words, f of g of x meant f of x minus 8. So here's in the parentheses. What are we going to do to it? Where are we going to stick x minus 8 in for?
For g of x?
Not in the g of x. We're talking about the f function right there. That says f. So we substitute it in for that function. There's the f function.
Okay.
Okay, so it would be 3 over, and instead of x, it's x minus 8. So that is f of g of x. Okay?
Okay.
You'll get it. This is the exact reverse, number 6. We'll talk about domain in a second. I want to make sure you understand this composite concept. Okay?
Okay.
So start with g of f of x. Tell me what that means. That means g of what?
You would put 8.
Hold on. Means g of what?
G of x.
That's what we're looking at. G of f of x. Well, what's f of x?
G. Oh, the numbers?
What is the function f of x?
3x to the -1.
Okay, so that's what we're going to put in the parentheses, which I can also write this way, correct? In other words, I don't have to write it 3x to the -1. I can write it like this. So this is our problem, okay? Now, go to the g function, and instead of g of x, we're going to do g of 3 over x. So what's that going to be?
Wait, what do you mean?
Here's the function we're dealing with. You know what? You'd be a lot better off if you do not look at your papers that are in front of you. That if you focus strictly on our common screen here.
Okay.
Because this is where I'm circling stuff, pointing stuff out, and I can tell you're getting confused because you're trying to jive what you're looking at here with what's on the papers in front of you. That's a mistake. You don't want to do that. Try to follow what I'm saying.
Okay.
Okay? So, first of all, let's start over here. We've got two functions. We've got an f function and we have a g function. Okay?
Okay.
What would g of 10 equal?
Wait.
Well, what do? What's the rule? When you have something in the parentheses, what do you do with it?
You put that in the x for x.
Okay, do that. What do you get?
30? What'd you do? Wait.
You're putting it in the wrong function. You got to put it into this function. This is the g function. The other
So you do
is
10
the f
8.
function. So what is it?
10 minus 8?
Correct, which is 2. So you put in whatever's in the parentheses into that function, the g function, not the f function. Okay, so depending on what it is talking about. Well, in this case, it's g of, and instead of a number or instead of a variable, they give you f of x. So this means equals g, that didn't change, but f of x, we don't need to write f of x. I'm going to write that function right there. So let's put it in as 3 over x. So that's the problem. Now we've totally eliminated the f of x part of this problem. In other words, f of x was only needed as to what we were to put inside the parentheses. Okay? Now, what is g? Let's cross that one out for the moment. What is g of 3 over x equal to?
You would put it into for the x, so it'd be 3 over x minus 8.
Okay. That's simple. Okay? All right, let's do another one. They're all the same. Once you get the hang of it, then these become a piece of cake. So here, it's f of x. So what is that equal to for starters? Give it to me as f of something.
3x, 3 over x.
Correct. Okay. Now, what is this equal to?
3 over x minus 8.
There's no more g function. We've already put in. There's no g function in this problem number 7. It's f of x. But regardless of whether there was a g function or not, once we get it into this format, we're done with the g function. Now, just go to the f function and stick in whatever's in the parentheses n for x. So what is this equal to?
The 3 over, and then 3 over 3 of x?
No, just that. Right?
Yeah.
In other words, it's I'm going to substitute 3 over x into the original function, which is 3 over x. So instead of this x, I'm going to put in there 3 over x. And now I have a number divided by a fraction. How do I solve that? How do I simplify that?
Wouldn't you get 1 over x?
What do you do? How do you divide by a fraction? If I said, what is 3 divided by 2/5? What would you do?
I don't know.
I said 2/3 divided by 4/5. What would you do?
Add them?
You flip the bottom and multiply instead of dividing. Pretty much all division problems can be done this way. If the bottom part of the division is a fraction, then you flip it and you multiply. In other words, that's equal to 2/3 times 5/4. You know what I mean by flipping it, right?
Okay, yeah.
And now it's really easy. That's 10/12, which can be reduced. So it's really easy to divide by fractions. Okay, what is 3 divided by 2/5 equal to?
You would do 5 over, no, you would do 3 times 5 over 2.
And what's that equal to?
15 over 2.
Okay, good. Now, let's involve a variable. What's 3 over x equal to?
You do 3 times x over 3.
Simplify that.
3x, or just x.
Just x. That's what number 7 is. It's just x. Okay? But notice we did exactly the same thing. In other words, we just used different functions. We didn't use the g function in number 7. And in number 8, we're not going to use the f function. We're only going to use the g function. So tell me how to rewrite 8. G of what?
G of x minus 8.
Okay.
Right.
Now tell me how I'm going to solve what is g of x minus 8 equal to. These are always two-step problems. This is the first step.
And then over.
Not over anything.
Over.
This is the problem at this point. There's no f function. Don't look at that. Here's our g function. So what do I do when there's something in the parentheses other than just x? What do I do? What's the rule?
Put the number in for x.
Not the number. You put the whole thing.
The whole thing in for x.
Whatever is in the parentheses in for x. Okay, so what does that equal to?
X minus 8 minus 8?
Correct. Which is?
Wait.
What's x minus 8 minus 8? You have to simplify these.
Would it just be x?
No. What's minus 8 minus 8?
0.
No.
Oh, wait. Negative 16.
Okay. All right, let's go on. Verify that f and g are inverse functions. Hold on. We need to go back and talk a little bit more about domain.
Okay.
Okay. The first one ended up, when we added the two, we had 6x squared, and it was, let's see, we had minus x plus 2, so it was plus this. I could write that like that, okay, which would be correct, but when you're looking at domain, it makes more sense to use the radical sign, because that restricts the domain. Remember what domain is. Domain is all possible values of x that you're allowed to plug in.
Okay.
Okay. Does the 6x squared restrict the domain in any way, shape, or form?
No.
No, I can put in any number I want for x. But the square root of x, what numbers can I only put in there?
2.
Can I put
Wait.
in 100?
Yeah.
Can I
Wait,
put
no.
in 3?
No.
You can't take the square root of 3?
Oh, wait. Yeah, yes, you can.
Okay. Can you take the square root of 0?
Yes.
Can you take
No.
the square root of minus 1?
Yes.
No, you cannot take the square root of negative numbers.
Oh, yeah, okay.
Okay. So that restriction means x has to be greater than or equal to 0. So that's the domain. Now, have they taught you interval notation?
I don't think so.
So they want you to give them the answer the way I've written it, just x has to be greater than or equal to 0?
Yeah, I think so. She doesn't want us to do the domain right now.
Okay, so we should ignore this part of those questions?
Yeah.
Okay, that's fine. She hasn't really talked to you that much about domain and range yet?
Yeah.
Okay. Let's talk about inverse functions. Let's do 11 first. Then
Okay.
we're going to go back and do 9. Let's talk about what an inverse function is. If f of x, on number 11, if f of x equals x plus 8, that means y equals x plus 8, correct?
Mm-hmm.
Okay, because f of x is the same as y. Now, what two things do you do to solve for the inverse of f of x?
You change it to x equals
You
y
switch
plus.
the variables, that's step 1, and then you solve for y.
Yeah.
Okay, that's it. That's the only 2 steps you need to do. Well, when I switch the variables, it becomes this. Now solve that for y.
Would you?
Don't look at your paper. Solve this equation for y. You should not have to look at any paper to do that.
You divide it?
Okay, x equal y plus 8. How do I solve that for y?
Subtracting? Wait, no.
Okay, let's talk about this. We need to go back some. This material is beyond what you know. Okay? So if we don't teach you the basics, you got no shot at any of these. So let's just talk about solving a very, very simple equation here. Okay? I want the final answer to read this, right? I want y all by itself. Well, what is currently over there with y?
8.
Okay. Is 8 a multiplier, a divider, being added or subtracted?
Added.
So you always do the opposite. So if 8 is being added, then I got to do what?
Subtract it.
Okay, and I got to subtract it from both sides. So I got to subtract it from that side, and I got to subtract it from that side. So the left now becomes x minus 8, and the right is y. So I've solved it for y. You don't care if the y is on the right side of the equation or the left. Does not matter. The key is you've solved it for y. Now, this y here clearly is not the same as that y there. And that's because what we solved for was the inverse. So instead of writing y, I'm going to write it with inverse notation, which is what the minus 1 means there. And that's equal to x minus 8. So there's your answer. And this is, in other words, once you solve for y, now switch it back and call it f inverse of x. That's how you pronounce that, f inverse of x.
Okay.
Okay? And it's that easy to solve for inverses. Let's do another one. You just have to remember 2 rules. Get it in terms of y and x, switch the variables, solve for y, whatever you get, call it f inverse of x.
Okay.
Okay, so let's do 12.
That looks confusing.
Well, we'll look at it. First of all, how do I rewrite it?
2x to the 4th.
First thing to do is to make it x's and y's. Right now we have f of x. We need to change the f of x to a y. That's always step 1.
Okay.
So there's actually 3 things. I mean, if they give it to you as f of x, then there's 3 things. You have to first of all switch the f of x for y. Okay? Now we got our second 2 steps. What's step 1?
You put it to y.
Swap the variables.
Mm-hmm.
That's not what you said.
Oh, I was reading
That
that.
put it to y or something like that. You swap the variables. In other words, wherever you see y, make it read x. Wherever you see x, make it read y. So when I swap the variables, this is what I get. Correct?
Mm-hmm.
Now, the third step is to solve that for y.
So would you subtract? Oh.
Okay, remember what we're trying to get to. We're trying to get to this. What do we got? What's the 2 doing? Right now, what is the 2 doing? And when I look at that right there, what's the 2 doing?
We're multiplying?
Correct. It's not being added. It's not dividing. It's multiplying. So what do I have to do to get rid of it?
Divide it.
Okay, so I got to divide both sides by 2. Okay, that got rid of the 2 over there and leaves me with y to the 4th equals x over 2. Now, what is this 4 doing? In other words, we got to get rid of that 4, right?
Would you have to multiply it?
No, the way you get rid of exponents is by taking the 4th root.
Oh, okay, yeah, okay.
Okay, so if I take the 4th root of each side, you could write that like that, then the answer is
x over 2.
And I'm not going to call that y. That is my final answer. I'm going to call that f inverse of x. Because that's what it is f inverse of x.
Okay.
Now, this is an extra little thing to it. And that is that x has to be less than or equal to 0.
Wait, sorry, what? It has to be...
This is pretty complicated here. I'm going to start with an easier example here. Okay? Let's go up and say f of x is equal to x squared. Okay? Instead of x to the 4th. I'm going to keep it easy. And they've added that x has to be less than or equal to 0. Well, that's fine. If x is less than 0, we're just going to square a negative number. Doesn't bother anything for the original function.
Mm-hmm.
But now, when I solve for the inverse, I get y equal x squared, and then I get x equal y squared. And then when I solve that for y, it's actually plus or minus the square root of x. That would normally be the answer. But the fact that I have said that x has to be less than or equal to 0 means that in the inverse function, it's y that has to be less than or equal to 0.
Okay.
You swap. When you take inverses, the domain of x becomes the range or of y, and vice versa. And when they say x has to be less than or equal to 0, that's saying the domain is restricted to negative numbers only, which tells me that when I find the inverse, which I have, then it's y that has to be restricted to negative numbers only. And what that means is I don't want the plus, I just want the minus part. So f inverse of x is going to be minus square root of x. Okay?
Okay.
Using that exact same analogy for 12, we come down and we get, if you remember right, we had x over 2 equals y to the 4th, right?
Yeah.
Well, when I take the 4th root, when you take even roots, your answer always begins with the words plus or minus. Okay? So when I solve this for y, it's true that I take the 4th root, but my answer is plus or minus the 4th root of x over 2. And that's equal to f inverse of x. Now here's the problem. They've told us that x has to be less than or equal to 0, which means f inverse of x has to be less than or equal to 0. Well, the only way you get it to be less than or equal to 0 is getting rid of the plus. So again, f inverse of x is equal to the negative square root, 4th root of x over 2. That's definitely tricky when you're dealing with domains like that, because you have to know quite a bit about inverses. And I'm not sure if you guys haven't covered domains and ranges, then you're not really going to understand how to do 12 properly. Okay. Because the key thing about inverses is that the domains swap and the ranges swap when you're talking about an inverse function.
Okay.
In the same way that you swapped the variables. In other words, wherever you saw y, you put x. Wherever you saw x, you put y. So you swap the variables, you also swap the domain and ranges. Now, let's look at 13. So what's the first step in rewriting 13?
Do the reverse. So you do y.
Give me the line to write. Don't describe it, because I don't know what your description means. Tell me the first thing I should write in order to solve 13.
You would do y equals negative x to the fifth plus 6.
That's what I'm talking about. When I say give me the first line, that's the first thing to do. Now what's the next thing to do?
Then you would subtract the 6.
Nope. You're missing a key step. Got to swap the variables.
Oh, yeah, okay.
Okay, so what's the next line?
X equals negative y to the fifth plus 6.
Good. And then finally, the third step is to what?
Add it?
No, well, the third step is to solve this equation for y. That's the third step, always. These three steps never change. The first step is if you're given an f of x, make it say y instead. The second step is swap the variables, and the third step should read solve for y. Now, how do we solve this for y?
You would subtract the 6.
Okay, that's step one in terms of solving the equation. Now we got to get rid of the negative sign and we got to get rid of the 5 exponent.
Divide it?
By?
The x.
No, the exponent and that negative sign are not related. That exponent of 5 does not operate on that negative sign. If I had parentheses like that, it would, but I don't have parentheses. So I want to get rid of the negative sign before I get rid of the 5, because the 5 doesn't operate on the negative sign. So how do I get rid of this negative sign? What's that negative sign doing right now? Is it being added, subtracted, multiplying, or dividing?
Subtracted?
No, it's actually a multiplier. That's the same as minus 1.
Okay.
Y to the fifth is being multiplied by minus 1. So what do I got to do to get rid of the minus sign?
Divide.
By minus 1.
Yeah.
And that gets rid of this. And it turns this into 6 minus x, believe it or not. Always. If you have a minus b and you divide it by negative 1, it turns it into b minus a. Okay? So this is what we're looking at. Now what? How do I get rid of the 5, the exponent that is 5?
Do you multiply it?
How do we get rid of the 4 over there?
Square root it.
Okay. You do what?
Square root it.
Not square root. Square root means you take square root. Cube root means you take cube root. What root do we want to take?
What's it called?
The 5th root. It's called whatever that exponent is. If that exponent was a 7, we'd be taking the 7th root. If that exponent was 1500, we'd be taking the 1500th. Okay, so when I take the 5th root, I just put a little 5 in there like that. That incidentally is also the same as the exponent of 1/5. In other words, up here on the right, the 5th root of x is the same as x to the 1/5 exponent. That's what fractional exponents mean.
Okay.
They mean the 5th root. Or if you had the square root, that would be a 1/2. Okay? So that's what's equal to y. Now, when you take odd roots, you notice that when we were taking even roots, the answer always comes out plus or minus.
Mm-hmm.
Whether you're taking the square root, it comes out plus or minus. Whether you're taking the fourth root, it comes out plus or minus. If you were taking the sixth root, it comes out plus or minus. So as long as you're taking an even number root, your answer is always plus or minus. But if you're taking an odd number root, it never is plus or minus. It's only plus.
Okay.
Well, it can be minus. In other words, if I take the cube root of minus 8, that's minus 2. But it's not plus or minus 2. It's minus 2. And if I take the cube root of plus 8, that's 2. So odd roots produce a single answer only, depending on what's inside, whether it's positive or negative. That's the sign that goes with the answer. So this fifth root, I don't put a plus or minus in front of that. The only thing I do is turn that y into the fourth step, calling it f inverse of x. Okay, so there's the proper answer. And it really wouldn't be correct to say that that's y, because that would give you the wrong impression that that y is the same as this y up here, and it's not. This y down here is f inverse of x, whereas this y up there was f of x. So I switched it to y only to make solving for the inverse a little easier. It's more confusing when you're staring at f of x and f inverse of x. So to me, I think the best first step is to always change your f of x into a y. Then swap the variables, second step, solve for y, third step.
Okay.
And then a fourth step, change that final y into f inverse of x. All right, now let's go back and do 9. Now, how do you prove that f and g are inverse functions? Here's how you do it. If f and g are inverse functions, then this has got to be true. So does this. Now, it's rare that a math teacher will make you prove both of those. In other words, you just have to do one of them. And once you get x as an answer, then you know that f is the inverse of g.
Okay.
Okay? So that's how we're going to prove all of these, is by proving that the composite, that, if that would have been equal to x, then these two functions, f and g, would be inverses of one another. Same thing with that. Had that been equal to x, it would have been inverses of one another. Now, oddly enough, that was equal to x, right?
Mm-hmm.
You'll remember, right? That came out to be exactly x. Well, what does that tell you? That tells you that f is an inverse of itself. In other words, f of x, the inverse of f of x here, is 3 over x. That's its inverse. And you can prove it by doing this composite and showing that it's equal to x. And we already did that, and we did get x. So that tells us that f is its own inverse, which doesn't happen very often. That's pretty rare. Very unusual for a function to be its own inverse. So
Okay.
when we look at 9, we got to prove that f and g are inverses of one another. So what is it that we have to prove? Tell me what I have to prove.
that 2x minus 3 is equal to half x plus 3 half.
Put this as a composite function. Think this.
That.
In other words, if it says verify. Now we're going to verify it by figuring out what the composite function is. And if the composite function ends up being x, then that's verification. So I got to figure out what f of g of x is. That's how I'm going to verify that g is an inverse of f.
Okay.
Okay. So first of all, tell me what f of g of x, how can I write that?
So the f is 2x minus 3.
Hold on. Start always from the inside and work your way out. So fill in g of x. In other words, this is what we started with. So what's g of x?
A half x plus 3 halves.
Okay. Now, we're done with g of x. Don't need it no more.
Okay.
Okay. We got to solve this. If that turns out to be x, then there are inverses of one another. So, how do you solve that? What's the rule? It's a real simple rule. You take whatever's inside the parentheses and you do what with it?
Add them.
Nope. You can't add these. These two things can't be added together. They're different. They're apples and oranges. The rule is you take whatever's inside the parentheses and you substitute it into the f function wherever you see x.
Okay.
So do that. Here's the f function. Wherever you see x, substitute what's inside the parentheses. What do you get?
You do half.
Hold
and
on.
then
There's a 2 right there.
Yeah, the 2x minus 3.
No. You take whatever's inside the parentheses and you substitute it into this function for x. Wherever you see x, you substitute 1/2 x plus 3 halves. So tell me how to write that, and then we'll simplify it.
A half. And wait, no.
Okay, start with the f function. It doesn't start out with an x. It starts out with a 2. So that's the way we're going to start out. Now we run into an x, okay? What am I going to write in place of x?
A half?
Whatever's inside the parentheses. What's inside the parentheses?
What parentheses? Wait, which parentheses? Like the half x plus 3 halves?
Yeah, that's what's inside the parentheses. I realized that my circle made the parentheses invisible, but apologize for that. Okay, so I've done the first part, but we still got this minus 3 up here. There. Now that is what f of 1/2 x plus 3 halves is equal to. You with me?
Mm-hmm.
Now, simplify that, and what do we get?
You would get...
Distribute the 2 to both terms.
You get 1x. And then plus 7 halves?
What's 2 times 3 halves?
3.5.
No, it isn't. What is 2 times 3 halves?
3.
Okay. Then it's plus 3. And now we still have this minus 3 over here. and the 3's cancel. Plus 3 minus 3 is 0, and that whole thing is equal to x. Therefore, we just proved that the g function is the inverse of the f function.
Okay.
All right. Yeah, we might have time for one more here. Number 10. Again, to verify that these are inverses, I'm trying to prove that f of x is the inverse of g of x. What has to be true if that is a true statement?
Wait.
What do we do on the other one? We'll do the same thing.
F of the. Hold on, I'm getting confused. The x cubed minus 3.
I think you're confused because you're not following my paper. You're trying to find stuff on your own end. Okay? And therefore, you're not really paying attention to what I'm saying fully. So that's the first thing, is try to listen to what I say, absorb it, and remember.
Okay.
All of these problems, what has to be true is that f of g of x has to be equal to x. If that is a true statement, then those two functions are inverses of one another. So our next step is to solve for f of g of x. Now tell me what f of g of x is, first of all.
X cubed minus 3.
It's f of x cubed minus 1.
I mean, minus 1. Why did I say 3?
Okay? So now we have to figure out what that is. Okay? Hold on, let me erase stuff that's taking up room here. So how do I do this? How do I figure out what f of x cubed minus 1 means?
You put the. What do you put?
Tell me what it is. In other words, rather than describing it to me, give me what it is. Give me the expression.
The x. Wait, the expression?
Mm-hmm. How do I simplify f of x cubed minus 1? What am I to do with this x cubed minus 1?
You put the f of x in there?
No, you put in what is in the parentheses. Always, whatever is in the parentheses, you substitute for x in the f function, not the g function. The g function's out of the picture now. We got everything we needed from the g function by substituting g of x, putting x cubed minus 1 in. Now we have to figure out how to simplify f of x cubed minus 1. So go to the f function, find wherever there's an x, and substitute x cubed minus 1 for that x. And tell me what to write.
So x cubed minus
1. That's for that right there. That's all it is. Okay, now keep going.
Then you add 1.
Yep.
To the third.
Okay. Now simplify that. What's minus 1 plus 1?
1.
0.
Right? 0.
Which means what you now have is x cubed to the 1/3 power. Well, how do you do that? When you have double exponentiation, what do you do with the exponents?
Do you multiply them?
Yes. You do one level less always. Double exponentiation is higher mathematically than multiplication. So you do multiplication, which gives you x. Okay. Therefore, those are inverses of one another.
Okay.
Okay. All right, Haley, it's a good place to stop. We got through at least through 13.
Mm-hmm.
I will talk to you next time.
I signed up for the next 3 weeks for the SAT, for like SAT prep.
Yeah, I thought we were going to be doing that tonight.
Yeah, I thought so too, but then I was like, I need to get this help.
Okay. Okay, I see the one on Monday and I see the one on Wednesday.
Yeah.
That one on Wednesday, I may have to change that. If you can change it.
What time is it at?
It's currently at 4 o'clock on Wednesday. I didn't realize I had a previous obligation and I let your mom schedule it too far out. I didn't know. I didn't realize she was going to schedule it out that far. So if there's a way we can switch the one on February 7th and nope, don't need to switch the one on the 14th. That's the only one I need to switch, is the one that's on February 7th.
Okay.
What, do you have a time you want to switch that to? I can do it right now if you know when you want to switch it to.
Wait, can we do a time on that day?
Uh,
Or no?
yeah, I could do later. I could do
Do you
8.
have time on, no. Do you have time on Tuesday?
Uh-huh. I have Tuesday almost all open here. But not at, I could do 5 o'clock on Tuesday. I could do 3 o'clock.
I'll do 5 o'clock.
Okay. Let me just move it over there right now.
Okay.
And everything else is good to go. So let me just make sure that I've got you down. So the next session you have is at 4:30 Monday next week.
Okay.
And that's going to be an SAT session?
Yeah.
Okay.
Okay.
All right, Haley, I'll talk to you Monday.
Okay. Thank you.
Bye-bye.
Bye.